Thank you everyone for being here and listening. I'm really honored to be here. Good morning, good evening, good night, whatever time it is for you. This is a worldwide event, so I'm sure it's not quite perfect timing for everyone. Thank you, Ramon. I'm trusting that I am not muted this time. Won't have to start this one 3 times in a row like last year. Awesome. So I like to give interactive talks. It's a little bit harder with virtual sessions, but we have the chat and we have Q&A inside of Hopin. Please do try to be active there, post things, and I will try to get to them when I can. If I don't get to them during the talk, I can definitely come back to them at the end. I'm saving time at the end for questions. So as we're going along, if you have questions about these things or anything else, feel free to put them in the Q&A, and I'll try to get to them at the end if I can't get to them during my flow. So, title of my talk, is there anybody else out there? This is PX4 Developer Summit 2021. My name is Tully Foote, and I'm coming to you from Open Robotics. Give you some background on Open Robotics if you're not familiar with us. We were established in 2012, originally called the Open Source Robotics Foundation. We're a small company, about 50 employees with a global team. We're spread, our primary office is in California, but we have a team in Singapore, Boston, Europe. We also have people in Japan, and all around the world as well. So, what are the primary things we do? The primary things we do are we work on ROS and gazebo ignition, as well as the historical gazebo, classic gazebo is what we're calling it now. Many of you are familiar with these. I'm not going to go into great detail, as I hope most of you are familiar. If you want to find out more, go to ros.org or go to gazebosim.org or ignitionrobotics.org. Those are websites, lots of research and pointers from there. Just a quick background. We'd like to break down ignition into a set of things that we pull together. It has physics, it has rendering, it has sensors, and it all comes together in a GUI so you can do physics-based simulation of robots. For ROS, we break it down in a slightly different way. We think about there's core plumbing that gets data from A to B. There are tools that help make you more productive. There are capabilities that build on top. And then there is the larger ecosystem, which is actually where a lot of the value is. The value is that you can take all these tools, they make you more productive, but then they help you collaborate with the greater community so that you can leverage other people's work from around the world, and the whole state of the art for the entire community keeps rolling forward. We got lots of great facts here. I'm going to keep rolling though for the sake of time. I want to give a little bit of a history of ROS. First commit was back in 2007. We were hosting ROS on SourceForge back then. The first ROSCon came out in 2012. Our first paper, which has been cited over 8,000 times, came out in 2009. And we've been going strong since then. There's been a lot of things going on. I hope most of you are familiar. So, gotta keep going. A little bit of history on Gazebo. Gazebo actually started before ROS, back in 2002. It was a project, a couple of students at USC, such as Nate Koenig, and, well, in particular, Nate. Willow Garage picked up support for it early on, and then Open Source Robotics Foundation picked it up and has been running with it ever since. I also want to point out with these histories, I'm blurring through them quite quickly. There will be a whole talk on this by my colleague Brian Gerke tomorrow in the middle of the session, or middle of the program, so I highly recommend you go check that out. A little bit more about where we are right now. I want to highlight some of the people that are companies that are active in ROS2 community. We have large corporate sponsors, which you can see here, as well as I want to highlight the technical steering committee for ROS2. This group is helping drive the innovation of ROS and push the development forward. Without their efforts, we wouldn't be anywhere near as far as we have been already. And also a quick thank you to our industry clients and government clients. All of these companies have been working with us to help develop ROS, and we've been working with them to make sure that their applications work as well too. This is part of what we do at Open Robotics. We provide consulting services for companies such as the previous list and many more. We use our robotics expertise and help companies spin up their application, get started with ROS, convert, improve, or add more capabilities for whatever needs their use case. So, background on the company, now a little bit about me. I've been doing robotics for quite a while now. Some of my highlights are that I started off working on the DARPA Grand Challenges, did them twice at Caltech, once with Robot Alice, once with Bob, and at UPenn I worked on Little Ben on the Urban Challenge. I've been at Willow Garage, worked on the Pier 2 and the Turtlebot there, and since then I've been at Open Robotics. Helicopters are a passion of mine. I have a couple drones, I love to play with them. I don't get as much time to work on them professionally as I do hobby. But it's really great to be here and be part of the community and help share some of the insights from the rest of the robotics community back to the PX4 community. I'm really happy to have been able to join you all last couple of years, talking about micro ROS and simulation. And you'll see a lot of continuation of that work in the rest of the program. I don't want to steal their thunder, so I'm going to also leave those topics there. But I do highly recommend checking out several of the other talks that are coming up later in the session. So for this talk, I want to take a moment on reflecting where we are and then think about where we want to go. The PX4 community is charging forward very rapidly. It's really great, but I don't want us to get stuck thinking about just the next step. I think that looking over the horizon, over the next hillside is important to do. We may not know what's there, but we do want to actually be prepared for when we get there and we can see a little bit farther into the future. This is a general community thing that needs to happen. There are people, there are leaders that are doing a great job leading this. But one of the values of the community is actually the community and the greater community insight. I want you all to be thinking about this and participate in the process defining the future going forward. All of your voices are important. It is our voices collectively that help give us the best guidance. And a lot of this I want to highlight because I see complexity is coming to this community. We're starting to look at beyond visual line of sight operations. And if you start thinking about taking it from, there's one person in a field with a drone controller and one drone, we're starting to see a lot more about swarms of drones. We're starting to see things where you start to have one person controlling many drones, or potentially multiple people controlling one drone and handing it off. A good example of the complexity that we're likely to start stepping up to as we get to more commercial industrial applications is if you just think about the standard process for flying on a commercial airline. Not only is the pilot flying the plane, the pilot's talking to air traffic control, they're talking ground traffic interactions, the cargo loading, there's passengers loading, there's manifests, there's check-in agents, you got to get the fuel, you got to get the water, you got to get the catering. All of these are systems that are interacting, and they have interfaces, they have moving parts. And as we grow the drone community, we need to start thinking more about what are all these other things that we're going to interact with, not just actually flying the vehicle. It's always flying the vehicle safely is super important, but where are we going beyond this? And what are the things that add the value to the customer, the user, etc. It's going to go beyond just flying the drone. So now I want to start thinking about where we are and what we're developing. In the current, we have very clear needs. We have capabilities. What can the drones do? This is the core of what the PX4 community has been doing. We have a lot of process and quality. We want to keep the quality up. It's important for everything we do. And we need to have a process to get there and make sure that everything is solid and people can rely upon it and it works every time. And how we do this is through collaboration. PX4 community is worldwide. Everybody's contributing. There were great some statistics in Lorenz's talk earlier today about how people are contributing and from where, etc. And it's a collaborative effort. There are big contributors and small contributors. All the contributions help get us that extra bit. And safety, wait, sorry, that's not safe. Safety. Safety is critical for everything we do. We always have to keep that at the forefront of our thoughts and planning and process. These are our immediate needs. But if we start thinking about more of the themes that I was talking about earlier, we need to start thinking about how to do abstractions, etc., to help us develop and customize. One of the things I want to highlight is that it's very important for us to do things like separate the business logic from the flight code. As I mentioned, the safety is super important. We need to have the autopilot flying reliably and just working. And the business logic that's going to be used for doing the specific application should not interfere with that core safety elements. We need to set up the right abstractions to separate out the business logic from the core safety systems. And beyond that, we need modularity to be able to also extend beyond the PX4 components. There's been a lot of talk about ROS and ROS2 integration, but there's other things out there. We want to be able to have a modular system that can be expanded. And as Lorenz mentioned, the power of PX4 is being able to customize it for different applications, whether you're doing crops, operations, cargo, just surveying, etc. You need different payloads, you need to plug them in. And the important thing to do is that we need to be able to leverage other tools, other communities, and things that are out there. Two of the great things that are already integrated with PX4 are Ignition Gazebo and ROS2. It's great to see those there. There's a large ecosystem of things that I've already mentioned that where you can pull capabilities from, bring them in, and then you don't have to implement them. And also, this will grow the greater community and we can all work together. Those tools are ones that I'm most familiar with. They're easy for me to cite, but I don't want you to get the sense that I'm saying those are the only things. There's lots of other great stuff out there. In ROS and Gazebo, we work very hard not to reinvent the wheel, not to bring, if somebody's already done something well, let's bring it in and integrate it and not try to re-implement it. And lastly, saving it for last, but definitely not least, because it's probably the most important, we need to make sure there's documentation. I have to congratulate the PX4 community. You are one of well above average on documentation. It's done you really well. It's helped with the growth, etc. But keep it up. It can always be better. And I just cannot emphasize that enough. So now, as we start thinking about, those are the needs that are obvious to us as developers. But as we're going along, we really need to focus outward and find out what our users and customers need. This can be done through surveys and need finding studies. Really go out and ask what people need, find out what is their, where you can add value for them, and then let's make sure that PX4 can get to that point and get coverage on that. It's important for us to go into unfamiliar territory and find out what we don't know, so then we can find those, identify the problems and then solve them. There's a lot of other people out there. They're doing a lot of cool things. Who is what might be a good collaborator or a good partner that you haven't thought about? Also, who might be a customer that you haven't even considered. Somebody who might not already be interested in drones, but will be if you go and make the right case. One of the ways that we've thought about this in the ROS community is that we set out to try to create the LAMP stack for robotics. So the LAMP stack, if you're not familiar, was Linux, Apache, and MySQL, PHP. There's a similar one, and sorry, that allowed the early innovation in the internet development, because you had open source software modules you could take off the shelf, put together, and make a project, a business, enact your vision overnight. There's modern ones such as Mean. For robotics, I've already given you the breakdown that we like to talk about for ROS, which is the plumbing, the tools, the capability, and the ecosystem. Bringing those together. And I challenge you to think about what this is for the PX4 community. How can we put that together? At the core, there's probably something like the autopilot and flying, but where do we go from there? And as I've mentioned, and Lorenz also mentioned earlier today, one of the powers of PX4 is the customizability. There's a lot of things out there, and we got to think about what lies over the horizon. We need to think about standard interfaces to enable people to put things together. We have all sorts of different types of drones. We're going to be looking at new forms of communication. Satellite connectivity is coming along, and it's likely we will have continuous connectivity. If not through satellite, there's also 5G. I believe there's a talk on that later in the program as well. You should go check that out. But in addition to that, I mentioned earlier, is we're going to start going to multi-controller and multi-vehicle systems. How do we get those to communicate? Collaboration. Are we going to collaborate with, there's collaboration during development, which I've already talked about, but there's also collaboration at flight time. If you're doing search and rescue, you can't necessarily have all of the communications go back through a central location. The control may need to be distributed. How do we facilitate that? How do we connect drones that have been launched separately and let them communicate effectively, even if they weren't planned to be collaborating when they were launched? There's a lot of really great stuff in this overall program for the event, and I highly recommend look through it, think about both what is being presented and what the next steps would be and where you'd like to see that going, and potentially kick up a discussion with somebody, because this is about the community. This is about connecting us, and the serendipitous connections that can happen when you bring the community together like this is really powerful. I'm going to come back to this topic again. We need open interfaces. We don't want to let a proprietary system define them. An example of this would be something like AWS and EC2. We now have open implementations implementing the AWS proprietary API because it was first mover and got out there and got critical mass. It would be much better if we had an open standard that everyone can buy into and have an open process for evolving it, etc. I was really excited to see Lorenz mount the PixHawk's PPD, PixHawk payload bus, or sorry, PPB. That's really great to see this coming along. That's a good example of an open standard, which will help the whole community come together and work independently, but then still be able to collaborate effectively. It's a good step towards swappable payloads. We're also going to need to be able to do things like share swarms and delegate autonomy. And those are important also for having open interfaces so that people can work independently. I can develop a controller, you can develop a drone, and we can make them work because they talk together. And of course, as we're doing this, preparing for what we don't know, we need to think about what other areas that are important to go into. We need to think about certification, encryption, authentication. What are the tools that are going to allow, that we can develop now that will enable us to get to future projects and make those happen quickly and easily because we've already laid the foundations today. So I want to give an example that I'm quite familiar with. This comes from the ROS development process. In 2013, we put together a workshop called ROS for Products. And this was a workshop that came out of the fact that we identified that ROS was being heavily used for research in academic and research labs throughout the world. Grad students were using it regularly, but we noticed that there was a disconnect because the ROS was not being translated from these research applications into commercial applications. And we brought together people from all across the community and worked with them to help identify what are the things that are preventing this transition from research to product. And we identified things that where we can improve ROS. One of the first ones was supporting bare metal microcontrollers. Product developers are very cost sensitive, as I'm sure you're all aware. And being able to go down to smaller microprocessors, microcontrollers is very important because you can bring the cost down, and also for this community, you can bring the weight down. There are a lot of applications out there that want to use real-time control. ROS1 did not have support for real-time control at all. You had to use things, firewall it off, and you bridge into a real-time system. Multi-robot systems was also another one that we identified in ROS1 as being not ready to do that, or it was not ready for product capabilities. So we wanted to make sure we improved that. And also, we needed to make sure that the gap between what you were prototyping with and your final product was smaller. We need to work on reliability, certifiability, and make sure that if something was developed in the research lab, you could convince a product manager to say, like, it's built on something solid. This prototype, we've built on top of the core system. The core system is fine for us to move over. We just need to harden the new implementation, as opposed to taking a ROS1 prototype and scrapping it and starting from scratch. And this product, ROS for Products workshop that we held, came out with these things. This is a slide that I pulled from a presentation shortly after that workshop. And I'm happy to say that these became the design tenets that went into ROS2, some of them. And now with these things, I'm going to highlight that we have a really great community built around this, building ROS on products. This process of reaching out and finding out what people need, finding out who's there and who could be potential users, who could be valuable partners, is important to do. This lets us do this and go help meet their needs, which lets us help grow the community and make it more valuable and useful. This helped us accelerate not only these members, but also a lot of our clients have been doing the same, are now on board. Most of these people were not active in the ROS community back in the ROS1 days, but they've grown up and helped us grow and accelerate the community. And I do want to highlight that this is not a one and done process. This is a continuous process. The ROS for Products workshop taught us to go out there, reach out and talk to people more, talk to people that aren't using it, talk to our critics, and find out what can we do to improve. And I want to highly encourage you all to just do that process for yourself, for the project, for your companies, etc. So, sorry. As I was preparing this talk, I was reminded with a recent interview with Melanie Weiss. She's now a VP at Zebra Technologies, formerly CEO at Fetch Robotics. I think many of you are maybe familiar with them. They've been doing logistic robots in a warehouse environment. But what stuck out to me with that interview was that projects and companies are not static. They evolve over time. Melanie had a very good example of this in her interview with Audro on her podcast, Sense, Think, Act. And the core of this is that Fetch started off as a robotics company. And what do you do when you're a robotics company? You build hardware. And so they built the Fetch and the Freight. And they went out there and they looked at the companies, they looked at who needed their services, etc. And they built a great robot, but it turns out a great robot wasn't really what they needed to sell. What they needed to sell was software that makes the great robot do something useful. And so after several months of developing the hardware and getting it working, they pivoted, and as Melanie says, they turned into a software company where they were selling software that used the hardware under the hood to make something useful for the company or for their customers. Now, as they were doing this, they built up more expertise, they built up the software, they got everything working more and more, and they started doing bigger deployments, larger spaces, etc. And they realized that where they were building up their value was not actually necessarily in the software. The software was, again, a critical step to making things work, which was building on top of the critical functionality of the hardware. But then they realized that the value of their system was not just the hardware or the software, but it was actually the data that they were collecting and aggregating as they were operating the software. They were collecting the data initially because it's how they made sure their process and quality stayed high. But they realized they can do things like use that data to improve other things, such as the customer's process and quality, and be able to provide that back to them as well. So I look at this and I think about the PX4 project, and I see a lot of parallels. There's been a lot of hardware work, and it's somewhat moved on to software. And I want to challenge you to think about, where is it going next? If you're started with hardware, your software, what is the next evolution? Where is this project going? What is going to be providing value to the community? And what can you do to be part of that process? So I'm really happy to say that the community is growing rapidly. It's awesome to see these conferences going on, more and more people coming together from all around the world, collaborating. There's lots of new connections being made, lots of new projects. There's a lot of focus on, obviously, the things that need to be fixed in the important time. But this community here at the Developer Summit, it's important for you to work together and talk and collaborate to help provide the direction for this. Reach out, make connections. I know it's a little bit harder in the virtual space here, but I do highly recommend it. Start conversations here, make connections, and continue them online afterwards as well. The open source community is so productive and can evolve so quickly, it's really hard to compete with. That's part of why you all have a chance to make a difference. Like a school of fish, if someone does something interesting, others will follow, and the whole school can benefit from those small decisions that are made independently of the larger body. And finally, I'd like to echo Lorenz's call for open interfaces once again. This is super, super important. This is how we're going to make this community continue to grow and be effective and efficient. So think about what you're doing and how you can standardize it and share it so that other people can interact with you, and you don't have to worry about the whole system. You only have to worry about your side of the interface. So with that, I'd like to thank everyone for listening and joining here. It's been really great. There's a lot of stuff out there, a lot of stuff happening. We don't all know, or none of us know exactly where we're going to be going next. But as you get going, let's start going down the runway and see where we get to. A quick call out. We're going to be hosting Ross World in October. I If you go to roscon.ros.org, you can find out more information. I hope to see many or all of you there. So, thank you. If you have questions, or I'll go to the Q&A. Thank you, Michael, for your thoughts about where we're going. And yeah, there's definitely stuff going to space. I think there's also some great talks on that as well coming up. Great. Oh, now I got it. There we go. Okay, let's start with the first one. What am I most excited about? Let's see. I think that for me, I'm most excited about seeing drones start to get into more interactions with real capabilities. As a helicopter pilot, I know how much effort and work goes into doing a safe flight and doing the operations. And I really believe that automating a lot of that can make things safer. And so as we automate more of this, as we get things safer, as Lawrence was talking about the adaptability, like say recover from a partial system failure, like suddenly we can get things safer. And I would really love to have the drone that can come like pick me up and take me somewhere and skip all this traffic. What's my opinion about using ROS between a drone and a minesweeper? I assume this is for like demining sort of things. I think that's a great application. I'm not familiar much with minesweeping in particular, but I think that as we have developed ROS 2, starting to do intra-vehicle systems will be very valuable, whether it be leading a minesweeper to a buried landmine or any other system where like drones are collaborating with ground systems. I think there's going to be mobile ground systems. My slide earlier, I had trains, boats, cars, laptops, cell phones. We're all going to be connected, and as we do that, the greater ecosystem will sort of go together, and we need to network all of that together. And I think that as we develop, hopefully ROS 2 can provide those links. Certainly for any specific application, we can make that happen. Are we going to contribute to Ignition on PX4 soon? We're actively working on Ignition all the time. We'd love to see more features. Did the project previously in collaboration with Arturian to get a bunch of worlds into the PX4 environment. We'd love to do more on that. We don't have a focused project right now, but we are working on new rendering engines, new physics engines, speeding things up. Basically, we're trying to improve the whole system, and we expect that should make major upgrades for the drone community as well as everyone else. Next frontier in robotics. Let me think a second. Don't have a good question on that. I think one of the biggest things holding robotics back right now is battery technologies. Once we get lighter and more compliant systems, that will help a lot lower the energetic requirements for each system. We need to get robots to the point that they can interact more more integrated with human environments. We're really good at building robots that we keep at a distance, but we really need to get them to the point that they can work side by side with us and we don't worry about it. This is one of the things that I was kind of spoiled with working at Willow Garage with a PR2. With most robotics arms, you keep it at beyond arm's length so that if it goes berserk, it doesn't hurt you or worse. With the PR2, if the arm went berserk, you could just reach out and grab it and hold it because it was passive, compliant arm with low power sensors and was gravity compensated. So that as long as the gravity compensation mechanism didn't fail, you could out arm wrestle it. Getting us to the point that we can do that and have systems that are safe enough to be strong enough to be useful, but know when to use their power to do it safely is super important, and it's going to be a really hard challenge going forward. And I think that's going to be one of our big challenges. Of course, we're going to space, the bottom of the ocean, and everywhere else as well. So lots of different directions to go. Generally speaking, should the focus of companies be on all three, software, hardware, and data, top quality anything, or make perhaps inevitable compromises while keeping the customer informed, maybe? Yes, it's true. You can't necessarily do everything. One of the things I would actually suggest trying to do is potentially find collaborators and decompose the problem and focus on one or two of the areas, not all three. We've seen this in the AMR space, where there are companies that build solid robots that can drive around, and then people take those and build a small customization on top of them and integrate that into the larger system. And in industrial robots, you actually have a very clear example of this, where there are the robot arm manufacturers, and then there are the integrators, which take the robotic arms, program them to do something specific, and assemble them all into the production line in the manufacturing facility. So there's one company focused on hardware, and one company focused on the software and integration. So, great. Is there anyone else have some questions? I've got a little bit more time left. If not, I will let you all go. And thank you all for your time listening. I hope you enjoy the rest of this conference and look forward to talking to you online. Thanks for joining.